All right, so a car with a mass of 1,000 kilograms is moving horizontally at 20 meters per second. It collides with another car moving vertically with a mass of 1,500 kilograms moving at 10 meters per second. The unit collides inelastically and moves at a 50-degree angle. What is the final velocity of the unit? So we could set up our t-chart here with our x and y's. Our initial momentum in the x is 20,000 kilogram meters per second. And we get that by taking our 1,000 kilograms, our 1,000 kilograms, multiply it by our 20 meters per second to get 20,000. And our final momentum in the x direction is equal to the mass of the entire unit, which is our 1,500 plus our 1,000 to get 2,500, times our cosine of 50, because as you can see in the diagram here, the velocity in the x direction is adjacent to the angle, therefore it would be cosine, times our final velocity. And in the y, our initial momentum would be 15,000, and we get that from taking our 1,500 kilograms times our 10 meters per second. And our final momentum would be 2,500, which is the mass of the entire unit, times sine of 50, since, as you can see here, the 10 meters per second in the y direction is opposite of the angle, times our final velocity. So since we know the final momentum must equal the initial momentum, we can set our 20,000 equal to our final, which is 2,500 final velocity times cosine of 50. And if you take our 2,500 times cosine of 50, we get 1,606.964. And then we can divide our 20,000 by that number to isolate our variable, which is the final velocity, to get a final velocity of 12.446 meters per second. So if you wanted to do an example of an inelastic collision, we can do that right here. So a ball with a mass of 2 kilograms moves at 3 meters per second in the x direction. It strikes another ball at rest with a mass of 3 kilograms. Ball 1 is deflected 45 degrees at a speed of 2 meters per second. Ball 2 is deflected 30 degrees in the opposite direction. What is the speed of ball 2? So if we set up our t-chart again, we can get our initial momentum of ball 1 equals 6 kilogram meters per every second, and we get that by taking our 2 kilograms times our 3 meters per second. And since ball 2 is at rest, the initial momentum will equal 0 since the velocity is 0. So if we look at our final momentums, we can get our final momentum of ball 1 is 2.828, and we get that by taking the speed of the ball, which is 2 meters per second after the collision, and we can multiply that by cosine of 30 and times our final velocity. So, and also we take it by getting our mass times our final velocity times cosine of 30. And if you multiply all that out, you get 2.828. And our final momentum of ball 2 is going to equal 3, which is the mass, and multiplied by the final velocity, which we're trying to solve for, times the cosine of negative 30, since the 30 is in the opposite direction, therefore making it below the horizon and negative. So if we look at our y's, we get the initial momentum in the y direction of ball 1 is 0 because it is moving horizontally. And of course, ball 2 is still at rest, so the momentum is going to equal 0. If we look at our finals, the final momentum would stay the same, 2.828. And the final momentum would stay the same for ball 2, except instead of cosine, it's going to be sine, because as we covered in this problem, it's going to be opposite of the angle. So, same as last problem, we can set our final equal to our initial. You can do this with either your x or the y. I'll do it with the x. So we can set our initial, which is 6, equal to 2.828, which is the final momentum of ball 1, plus 3 times the final velocity times the cosine of negative 30, which is our final momentum of ball 2. And so if you do the math here, you can divide 6 by 2.828 and then divide it by 3 to get 2.121. Then you are going to take, so you get 2.121 equals the final velocity times cosine of negative 30. And if you multiply the final velocity, if you divide 2.121 by cosine of negative 30, you get a final velocity of 2.949 meters per second. So that pretty much covers it.